Welcome to Think Global Education Services. Today's topic is units and measurement. So physics, it describes the laws of nature. This description is quantitative and involves measurement and comparison of physical quantities. To measure a physical quantity, we need some standard unit of that quantity. For instance, first we can describe what are the physical quantities. The physical quantities can be classified into two types. One is the basic or fundamental quantities, and other is the derived quantities. So we have fundamental or basic quantities, and all the other quantities, all the other physical quantities are derived from the fundamental quantities. So they are called as derived quantities. The units of the fundamental quantities are called as SI units or International Standard for units. And there are 7 SI units or 7 fundamental units or 7 basic units for 7 fundamental quantities. So we can describe the 7 units. The first one would be length. Length is a fundamental quantity. We can write that as length. And the SI unit for length is meter. And meter is represented by m. Second quantity is mass. Mass is a fundamental quantity again. And the unit of mass is kilogram. And which is represented by kg. The third fundamental quantity is time. And the unit of time is seconds, which is represented by s. You can also write SEC. And the fourth fundamental quantity is electric current. So we can write that as ampere is the unit of electric current, and which is A. Now fifth fundamental quantity is thermodynamic temperature. So you can just write it as temperature. And the unit SI unit of temperature is Kelvin, which is represented by the letter K. And the sixth fundamental quantity is amount of substance. You can just write it as amount. Amount is nothing but the unit of amount of substance is mole. And the seventh fundamental quantity is, seventh and the last fundamental quantity is luminous intensity. And the unit of luminous intensity is candela, which is represented by CD, and mole is represented by MOL. This is Kelvin. This is amperes. And we know it is seconds. And kilogram. The meter. Now, how can we define 1 meter? So if we know an object is, the length of an object is 1 meter, so how can we define 1 meter? So 1 meter is the unit of length, and 1 meter is defined as the distance traveled by light in vacuum in 1 over 299,792,458. That is 299,792,558 seconds. So this is the distance traveled by the light in this part of a second. That is called as the 1 meter. And what is 1 kilogram? 1 kilogram is represented by a prototype which is kept in a secure vault, and the prototype is nothing but which is the mass of a cylinder made up of platinum iridium. So platinum iridium alloy kept at the International Bureau of Weights and Measures. So platinum iridium alloy cylinder, which is kept in the Bureau of Weights and Measures, is used to define 1 kilogram. And what is 1 second? So 1 second is defined by radioactivity. That is, first we need to know about Cesium-133 atom. Cesium-133 is a radioactive atom which emits electromagnetic radiation of several wavelengths. And each radiation corresponds to the transition between two hyperfine levels of ground states of Cesium-133 atom. That is, atoms have various energy levels, and when electrons travel from one energy level to other energy level, they radiate some energy in the form of radiations. They release some energy in the form of radiations. And each radiation has a time period of repetition of certain characteristics. The time duration in a particular cycle of this energy level is defined as 1 second. And how can we define 1 ampere? So 1 ampere is defined as, we have to take two long straight wires with negligible cross section. That means their cross section is very, very, very small, and they're very, very long. And they are placed parallel to each other in vacuum at a separation of 1 meters. And electric currents are established in the two in same direction. So electric current is posing, let's just say it is posing in this direction, and here it is posing in this direction. If equal currents are maintained in the two wires, so that the force between them is, the force between these two wires is now 2.2 into 10 to the power minus 7 newtons per meter of the wire, the current in any of the wires is called as 1 ampere. Now, how can we define Kelvin? So Kelvin is defined as the 1 by 273.16 of the thermodynamic temperature of triple point of water. Thermodynamic temperature of triple point of water. This is the characteristics of water, which is used to define Kelvin, and amount of substance mole. So the amount of substance that contains as many elementary entities, that means as many molecules or atoms. The substance is monatomic, as there are a number of atoms in 0.012 kilogram of 0.012 or 12 gram of carbon 12 is called a mole. That means, let's just say if we have a particular atom and we have to count at the number of molecules there is present in this atom, when this amount is equal to 12 gram of carbon 12. Carbon 12 is an isotope of carbon, and this is called as 1 mole. And luminous intensity is represented by candela. So candela is nothing but, it is the luminous intensity of a black body of surface area 1 by 600,000. It is 600,000 into 10 to the power, 600,000 meters squared, placed at a temperature of freezing platinum and at a pressure of 101,325 Newton per meter squared, the direction perpendicular to the surface. That means a black body is nothing but, we can take a star as a black body. Luminosity is nothing but the total power emitted by the star in 1 second or in a given period. That is the luminous intensity, which is nothing but a power. So star is a, let's just say star is a spherical object, so we have to consider the surface area of the star and all the power emitted by the star comes from its surface. So that's the reason why luminous intensity involves surface area. So now you got the fundamental units or SI units. So all the other units, which are called as derived units, are derived using the fundamental units. For example, we can take force. Force is defined as mass times acceleration, and the unit of mass is kilogram, and the unit of acceleration is meter per second square. So unit of force is kilogram meter per second square, or we can also write it as Newton. And now we can write a unit of speed. Speed is distance by time, which is nothing but meter per second. And we can derive various other units as well. So after the units, what do we have? We have dimensions. So what are dimensions? The dimensions are nothing but physics deals with the smallest of particles to largest of particles such as stars, black holes, and galaxies, like that. So let's just say we have various other dimensions with which we can measure objects. For example, the prefixes which will occur in most of the calculations in physics, we can discuss about that. That is power of 10, how to call the power of 10, and how to recognize the power of 10 symbol of the power of 10. So first we have 10 to the power 18, which is called as exa, and it is represented by the symbol E. For example, now here, if we have kilograms, here kilo represents 10 to the power 3. So 10 to the power 3 grams, that's what is kilograms. Likewise, hexagram is 10 to the power 18 grams. So if we have petagrams, that is 10 to the power 15 is peta, which is represented by capital P. And 10 to the power 12 is tera, which is represented by capital T. So let me just write it as a tabular column. Now we can begin with from where we left off. So first we have 10 to the power 18. So here it will be 10 to the power to the power. So first here it is 18. 18 is exa, represented by capital E. And then we have 10 to the power 15, which is nothing but beta, which is capital P. And then 10 to the power 12 is tera, which is capital T. And then 10 to the power 9, which is giga. And giga is represented by capital G. We can have gigabytes, gigaamperes. It will be a lot of current. And 6 would be megawatts. So capital M. And 3 is kilo. It will be represented by capital K. And then 2 is hecto, H-E-C-T-O, hecto, which is represented by small h. And 1 is deca, that is 10, just 10, that is what is 1, which is represented by dA. And we will normally write 10, we will normally multiply the 10 and write it as a rounded quantity. And we have -1 is deci, and deci is represented by small d. And then we have -2 is nothing but centi. Centi we will represent it as c, centimeters. And -3 is milli. Milli will represent as small m. And then -6, micrometers, microorganisms, so which we will represent it as using the Greek letter mu. And then we have -9, which is nano. We can represent nano as small m. And then -12, which is pico. Pico we can represent it with small p. Now we have to differentiate between here capital P, which is peta, and small p, which is pico. This is small p. And capital P will be bold and small p will be written in a small letters. And then we have 10 to the power minus 15, which is femto. And then at last 10 to the power minus 18, which is atto. And femto is represented by small f and atto is represented by small a. So these are some of the prefixes which we'll use to represent physical quantities. For instance, let's just say 10 to the power 15 meters. We can write that as peta meters. So we can say the words, say how much the quantity is. So if the quantity is very big, we don't have to say 10 to the power 15 meters. We can just say peta meters. That will be easier to remember. So this is the units and measurements, and thank you for watching.